Hi everyone, in this video we look at another example of graphing a transform function. So here we're told on the grid below, graph the function g of x is equal to 1/2 x minus 1 cubed. So the first thing that we have to do is identify the parent function. Here the parent function is y is equal to, let's write this using function notation. Let's call it f of x is equal to x cubed. And this is the parent function because I can write g of x in terms of this parent function. I can rewrite g of x in terms of f of x using the transformations that we've already learned. So how do I write g of x in terms of f of x? Well, I know that if I look at the equation of g of x and I look at the equation of f of x, it becomes quite apparent that g of x is equal to f of 1/2 x minus 1. So if I plug 1/2 x minus 1 into f of x, I get g of x. Now, there's something that's really important here. If you have a coefficient beside x inside of a function, you have to, in order to transform this function, you have to make sure that this coefficient is factored. So you have to factor that coefficient out of the two terms inside of the function. So I have to write this as, well, g of x is equal to f of 1/2 times x minus 2. All that I did was I divided 1/2 x by half to get x, and I divided -1 by half. If you divide -1 by half, you get minus 2. So g of x is related to f of x in the following ways. It's g of x is equal to 1/2 times x minus 2 in brackets. But now that this is written in factored form, I can think about what transformations are applied here. So this factor of 1/2 is a horizontal stretch of f of x by a factor of 2. So we have a horizontal stretch by a factor of 2. X minus 2, when we subtract 2 here, this is a horizontal translation right 2 units. So horizontal translation right 2 units. So these are the transformations I have to apply to the parent function. Let's first graph the parent function and see what it looks like. So my parent function is f of x, which is equal to x cubed. It has key points 0, 0, 1, 1, 2, 8, which is right here. We also have points -1, -1, and -2, -8. So now I can sketch a curve through these points. So this is f of x. Now let's think about what the graph of g of x is going to look like by transforming the key points on f of x. So the first transformation I need to apply is a horizontal stretch by a factor of 2. So if I take this point, the origin, and I stretch it by a factor of 2, it just stays at the origin. Because the distance between this point in the y-axis was 0. If I multiply a distance of 0 by 2, I still get a distance of 0 between this point and the y-axis. Next, I'm going to stretch this point horizontally by a factor of 2. If I multiply 1 by 2, I get 2. If I stretch this point by a factor of 2, I'll get a point here. If I stretch this point by horizontally by a factor of 2, I'll get a point here. And if I stretch this point horizontally by a factor of 2, I get a point here. Now that's not the only transformation that's been applied. So this is the graph of, it's not the graph of g of x. This is the graph of f of 1/2 x. Now I need to apply a transformation 2 units to the right. So I need to move all of these points 2 units to the right. So if I move this point 2 units to the right, I have a point here. This point 2 units to the right, I have a point here. I'll have a point here, a point here, and another point right here. So this graph is the graph of g of x. Let me use a darker color here because the graphs are going to overlap. So the graph of g of x looks like this. So this is the graph of g of x. And remember that g of x can be written in terms of f of x because g of x is equal to f of 1/2 times x minus 2.